Amanda Kaunda, and I'm here to present the Medicos Predictor application that helps in predicting the medical insurance cost of a person based on personal factors such as age, their body mass index, the number of children, and also their smoking status and other factors. So this application is built on three major components, which are the machine learning model, the API backend, and also the friendly user interface. So I'll do a quick demonstration of how this app is able to make predictions based on the personal factors. So we're going to predict the insurance cost of a 25-year-old female and has a BMI of 20, and she has one child and she's a smoker. So smoking status, yes, and the region, she's from the southwest of our country. So let's calculate the insurance cost and see how much it is. It comes out in dollars and it's 15,473.50. So I'm going to store this value, 15,473. And what if this person wasn't smoking? Then let's put no. Then the insurance is almost like lower. It's three times less. That means it's now $5,310, which is much lower compared to the previous. So that means the smoking status of a person affect the cost of insurance. So it either goes higher depending on the status smoking of a person, or lower. Yeah. The API was actually deployed on render. So I'm going to the docs Swagger UI to test this API to see if it actually works. So I'm going to use the same values I used in the app to show that this backend really works. So I'm going to use the post method and I'll click on try it out. And I'll enter the age of that lady. She's 20 years old. She's a female. She has a BMI of 20 and she has one child. Let's put the smoking status as yes to see if it's going to predict the 15,000 that we found in the previous. So the smoking status is a yes, and the region southwest. Yeah, we're finding the same value, 15,395.50, which shows that the backend is working. So for the linear regression model, I used a medical insurance data set. So for this medical insurance data set, it's a data set that contains the age, sex, and also the number of children that a person has, and would use that to predict the medical insurance cost of this particular person. So I trained three models: the linear regression from scikit-learn, the decision tree model, and also the random forest regressor. So each of these models has their own mean squared error, which is for 0.7 for the linear regression and 0.73 for the decision tree regressor and 0.8 for the random forest regressor. And in this case, we chose the random forest regressor because it's good at nonlinear relationships and feature interactions, which allows random forest to excel at capturing these nonlinear relationships. So in our case, since we're using the non-categorical data, that is like the smoking status and also the sex of a person, this is non-categorical data, and it's only the random forest regressor that is able to capture nonlinear relationships and help us in making accurate predictions of our medical insurance costs. So another reason why we chose it is because it has a built-in feature that helps in feature importance, showing that smoking, age, and the BMI are the influential factors in predicting the cost of insurance. So the smoking status of a person is the one that really has a greater influence. That means if a person smokes, that means they higher their medical insurance cost because definitely they would be damaging their lungs. Yep. So I saved this training model and used this model to come up with an API that I deployed on Render, which provides a reliable endpoint for making predictions on different interfaces.